All right, welcome to the first of its kind, world-changing manufacturers network. Lisa Ryan has her ears to the ground and her heart in the game. Get ongoing education and new connections right here with Lisa and the Manufacturers Network. Buckle your seat, listen, and spread the word. Here's Lisa.
Hey, it's Lisa Ryan, and welcome to the Manufacturers Network podcast. I'm excited to introduce our guest today, Christopher Nguyen. With a career spanning 4 decades, Christopher's tech bona fides are second to none. Since fleeing Vietnam in 1978, this multiple-time tech founder has played key roles in everything from building the first flash memory transistors at Intel to spearheading the development of Google Apps as its first engineering director. Today, he's become an outspoken proponent of the emerging field of AI engineering and a thought leader in the space of ethical, human-centric AI. With his latest company, Aitomatic, he's hoping to redefine how companies approach AI in the context of life-critical industrial applications. So, Christopher, welcome to the show.
Hi, Lisa. Thanks for having me.
Share with us a little bit about your background and what led you to doing what you're doing now with AI.
I guess the most relevant thing about what I'm doing now can be thought of as a failure, starting from after the acquisition of my previous company by a company called Panasonic. We all know Panasonic as a global engine. A lot of people don't realize that Panasonic is less of a consumer company than an industrial company, manufacturing avionics, automotive, and so on. And the acquisition of my previous company was to apply AI and machine learning to that global engine. And very quickly, we found that a lot of our, let me call it Silicon Valley techniques of digital first companies like Google and Facebook and so on, Twitter and so on, runs into very clear limitations right away when it comes to dealing with the physical world. The discussion or the debate between atoms versus bits and so on. And so we've had to develop a whole bunch of techniques that involve leveraging a lot of human knowledge, human expertise, and automating all of that together with machine learning to solve these industrial problems. So that's the thesis of Aitomatic, the company.
So how do you do that when you talk about taking that human knowledge? How are you taking that, what we do almost automatically as human beings, and turn that into machine learning?
Yeah, maybe I can share why we do that in the first place. Because to a lot of us today, that is actually counterintuitive. We thought the future is data-driven only, and we only collect enough data with sensors on machines, and then we just feed them into these machine learning algorithms, and they'll know and they'll predict and they'll do everything for us. It turns out that doesn't apply, not today and not for a very long time, to the physical industry. Take the problem of trying to look at sensors on a machine, like a refrigeration system, and then trying to predict, right? Tell in advance, is this likely to fail over the next 2 weeks, right? Is the compressor going to conk out or something like that? And it turns out that, in short, in order to do that, we need to rely on human expertise because it's actually not in the data that we're collecting. It's in their life experience, 30, 40 years of seeing various refrigeration systems, different models, different operating conditions, and so on, then building up a set of intuitions in their minds over time. We failed trying to do it the other way, and we succeeded, incorporating human knowledge. And so that's the reason we do that. And I can talk about, how we do that.
Yeah, I mean, that's so interesting, because when you have somebody that's been in a job for 20 or 30 years, and like you said, that's that feeling, that intuition, and being able to take a human feeling and turning it into data, that's just fascinating. So yeah, if there's an easy way to describe how that happens, that would be really great to know.
If we learn as humans, right, these are essentially, we're building learning machines, and we can either learn from examples or we can learn from instructions, right? Data-driven machine learning is essentially learning from examples. Now, learning by examples require lots and lots of examples before you start to build up some experience around it. But learning from instructions, you could say if the temperature is too high, but the pressure is too low, then signals something that may be problematic in the near future. So the basics of codifying or encoding human knowledge is about capturing some of these rules. Now, that has been done in the past, right? There are so-called expert systems where people try to do these things. But advances in technology, it turns out machine learning itself is enabling us to do this. We can take natural language. You and I can speak like this, and then it can be translated in something that a machine can understand. So then we can sit down with a domain expert, a manufacturing assembly person who knows the machine really well, and they can say, the sound that comes off of that sounds like the knock-knock sound of an engine. Then I know to take that offline. We can take the sentence as is, and now our machine learning algorithm can understand that sentence and then translate it into code. And then that code becomes automated and become part of the knowledge set that operates the automated system.
Wow. Well, one of the surprising things, because we talk about automation, we talk about AI like it's so widely used, and yet according to your information, only 9% of manufacturers are currently leveraging it. So what are some of the challenges that you've seen that have really stopped that from expanding wider?
Right. So one of the challenges, or one of the successful surprises that I've learned in the last 5 years being part of Panasonic, before launching this company, Aitomatic, is that the meme or the fear is that these robots are coming to replace us, to replace thousands of people, and we could just put a bunch of robots doing that. It turns out, let me use the word profitable, the most promising applications are not that, right? It is more about solving the problem of not having enough humans, about not having enough expertise. So in one example, we have, because it's Panasonic, we also operate in Japan. There are these large supermarket chains, right? And they run refrigeration systems. There are 10,000 supermarkets in one chain, hundreds of thousands of refrigeration equipment. And there are 3 experts in the entire country that are qualified to diagnose this, right? And so it's very much human expertise constrained. And so the solutions is to try to codify what they know, their lifetime of experience, and then try to replicate to scale that, right? Here in the US, we're sort of facing, I would call it the same crisis, right? In the last 30, 40 years, we've all gone software, right? We've outsourced all manufacturing, all of the tooling, all the physical stuff. And now we're finding that it's actually not just a economic risk, but a geopolitical risk.
One, especially with such a labor shortage that we're facing right now. So there's 2 sides of that equation. Number one, it's great to have automation to do the jobs that nobody else wants to do, that we can start making people's lives easier while requiring fewer people. But on the other hand, if you're talking about you have 3 people in an entire country that has that knowledge, there's got to be some fear around, well, if I communicate everything I know to the machines, then I'm going to communicate myself out of a job. So how do we balance that we can get away from the fear of that we can both work in harmony between man and machine?
Yeah, I'll give you an example here in the US, right? You may have heard a company called Husman, right? They make refrigeration equipment. They are a Panasonic subsidiary, very large operator. They sell into supermarkets in the US. If you go into the freezer section, chances are you'll see the Husman logo. In order to build, run, and operate such a network, it's a nationwide network, you need traditionally you need a very large force of service personnel, right, who understand this equipment, who have experience, who can go out and repair them. It turns out there's a huge shortage of people willing, able to take these jobs. What does Husman actually do? Believe it or not, they actually set up universities or schools to try and teach these people, and it pays very well. So this is yet another example where actually we're short on people willing to take these jobs, right? Because everybody goes to college and everybody gets a computer science degree. AI, machine learning, is going to try to help solve those problems first, rather than working people out of a job.
Right, exactly. And we certainly need both. I know I was talking to my mother today, and her air conditioner went out. Well, she's in Atlanta, Georgia, where it's 100 degrees today, and she's in her late 70s. And there's nobody that can come out. They have nobody to come out until Monday. So the labor shortage is real when it comes to not only people's health, like my mother's air conditioning, but also what you just said with tens of thousands of air conditioning units, that how do we get the people to do that?
Yeah, that's such an important example of what you just shared, right? Which is there's a field called predictive maintenance, in manufacturing and in instrumentation and so on, where we try to prevent failure. It's better than predictive maintenance is better than even preventive, because in preventive maintenance, you go out and you replace everything, every 6 months, and maybe there's a bit of waste, right? But predict means you can actually try to predict that something is likely to fail. The value of being able to do so is far more than the cost of that piece of that compressor or the labor to go out. It's actually life and death situations, right? It's not like a Google where you click on the wrong ad. Okay, well, somebody paid 20 cents for that. If you are trying to essentially build an intrusion detection system, cybersecurity for automotive, because in the near future, cars are actually computers on wheels and they're going to be hacked. If you get that wrong, someone dies. So I think this is a very important combination, that is to apply AI machine learning to the very important processes in our lives. We're still physical people. We still drive cars. We still eat fish and so on. The impact of failure can be quite consequential.
Well, and the interesting thing that you just said about the predictive is that I guess Carrier reached out to my mother yesterday via email to let her know that they sensed something wrong with her system. But unfortunately, AT&T was putting in fiber and somebody cut her line and she didn't have internet. So it's kind of a perfect storm. But that predictive maintenance is such an interesting concept, because if they can let you know that, hey, there's a really good chance that we're seeing something that's not working, then you can send those people that we have so few of to begin with to fix that or do preventative maintenance, because they know that there's a good chance that it's going to fail.
Yeah, that's right. And, a typical factory floor, one failure can shut down the line, and that's $20,000 an hour easily, right? It's not the cost of that screw or that compressor that you're trying to replace. The ability to prevent that from happening has a very, very meaningful economic as well as human life value.
Yeah. Well, and you also brought up an interesting point that kind of ties in right with AI and automation, and that is cybersecurity, because the more that we outsource and automate and take it out of the human control and put it into machine control, there's a couple people out there, one or two, that are the bad guys that are threatening that. So what are some of the things that you've learned as far as the risks? And I also know you talk about putting that human intelligence back into the driver's seat when dealing with cybersecurity.
Yeah, you may be familiar with what's called the Spy Car Act being, legislated, put up for legislation in the U.S. Spy Car stands for safety and privacy in your car. The U.S. Senate like to have these clever acronyms.
Okay.
But essentially, by a certain year, it was originally envisioned to be 2023, but maybe pushed out a little more than that. All cars on the road must have what's called an IDS, or intrusion detection system, right? Because cars are becoming computers on wheels. As I mentioned, they are subject to attack. And the way technology has been built is that when people first computerized the car, right, there's something on the car called the CAN bus, which you think of as the network. You have all these sensors and actuators and the processors talking to each other. Security, when that was first built, was not top of mind, because the car is a moving thing and who's going to connect to it and hack it. But now cars are getting connected. And there's been demonstrations, as far back as 2015, when there was a Jeep Cherokee that was, controlled to be driven off the road. And because it is life and limb, it is human life at stake. And it's not just, again, clicking on the wrong ad. Congress is trying to get ahead of all of this and requiring that manufacturers must put these intrusion detection systems into cars. And at Aitomatic, my company, we provide some of the intelligence that goes into that, because these things have to be essentially what's called anomaly detection. We are able to see communication patterns in the car that have not taken place before. And so that may indicate a kind of a cyber attack going on. And then being able to alert the driver and perhaps, shut down the systems before it goes too fast and cause somebody's death.
So as the hackers get smarter and smarter and outwit that, is that something that you're just always monitoring and looking at and patching? And I mean, how does that work as you're getting better, but chances are good that they're getting better too? So how do you continue to protect these devices, these cars and trucks?
It is an ever escalating battle. And the hope and the wish, and I think the promise is that machine learning or learning machines can be better than machines that were, let's say, not learning. Computers are actually pretty dumb, right? All of the intelligence in computers is actually coming from humans. We tell them exactly what to do. We tell them step 1, do this, step 2, do this, and so on. So that they're very inflexible. But when you apply AI and machine learning, the hope is that because those machines are now learning, they can adapt, right? And so they can adapt sufficient in such a way that they can see new patterns faster than we can sort of expect to have sort of human response and patch some system. They essentially can begin to patch themselves. So that affords us not perfection, but an additional layer of defenses, before things get really bad.
Wow, that's really fascinating. So what is it exactly that you do at Aitomatic? Tell us a little bit about your services and how you work with your companies.
Right. So some of the use cases that I mentioned, right? Refrigeration, predictive maintenance. There's also counting the number of fish under the ocean using sonar, echograms, and so on, for keeping fish fresh, and for something called fixed net fishing off the coast of Japan, as well as cybersecurity, automotive cybersecurity, and avionics, and so on. These are the various use cases that we don't implement directly, that our customers do, right? So these customers have teams, they're called AI engineers, right? You have computer engineer, you have software engineers, and now you have this emerging group of people, skill set called AI engineers. They use Aitomatic's tools. So we have tools and we have a cloud service that enable them to build these systems. We offer the capabilities that I just mentioned here. What they do is they integrate them together in certain ways to fit their particular use cases.
And so if somebody listening to this show today, I mean, we talked a lot about AI and some of what's going on and the small percentage of manufacturers that are currently leveraging that, as well as automotive cybersecurity. But what would be your best tip for somebody who is looking at taking their manufacturing to the next level of using that human intelligence along with automation to deal with whether it be the labor shortage or the technology? So what would be some of your best tips for somebody listening today?
True to what our expertise and what we believe in, there are lots of tools and techniques out there for someone to get into machine learning, to develop AI solutions. If they believe that they have an asset that is a human expertise, right, from years of experience and so on, and they want to apply that to their AI system, then I think they should seek out tools and techniques, companies like ours that specialize in something I call knowledge first AI.
Does your tool, you mentioned earlier about just being able to talk to it in normal conversation, it sounds like a knock knock when it does that, or how would you even know what to say to the machine?
So the speaking to it or the communicating to it in natural language, that's the first step on the journey. That starts the knowledge encoding, right? And once that knowledge is encoded, we then automatically generate what's called a machine learning model. And then the whole thing gets deployed into production. And once it's in production, data is still coming in. Incidents happen, new events occur. All of that is then, look back into rebuilding or refreshing the system. So essentially, the whole thing is an operating system that learns from human instruction, and as well as more as data comes in, it'll also learn about what's happening in real time.
And are there some industries that are better than others when it comes to using AI, or is it across the board in manufacturing that really everybody can benefit?
Yeah, absolutely. I think that's a great question, because there's nothing that is best for everything. The difference between the digital industry and the physical industry, and I used to be part of the digital industry, right? I used to be at Google and so on. There are tools and techniques that work with what's called big data that move very fast, digits in, digits out, and the processing itself is also digital. So that works very well for certain classes of companies. I think for manufacturers, for automotive companies, for avionic company, anything that has a physical dimension, we find that those tools and techniques don't work. And we need to have this human expertise. And so I think for a company like Aitomatic that focuses on what's called knowledge first AI, I think it's much more suitable for the physical industry.
Well, and the other thing that just popped into my mind too is as we look at the graying of America in manufacturing, and we have all these people who are walking out the door and taking that knowledge with them, it also gives them a chance to leave a legacy of take all of those decades of information and not only feel relevant because they're contributing to the future of the company, but truly to leave a legacy with the knowledge that they've built up in their career.
Yeah, for us, they're not just relevant, they're important, literally, right? And in some cases, this knowledge is lost forever and then has to be somehow built up again from raw data. And that's very difficult to do. Essentially, I like to, eventually 50 years from now, machines will learn everything. But what do we do in the intervening 50 years, right?
Right. Well, and we take advantage and we listen to the people that we have, because as I speak a lot on the show about workplace culture and helping employees feel that they're valued, appreciated, part of a bigger mission. And in this case, like you just said, with that human intelligence, that human factor, bringing it in, that can also really, in those conversations, let the managers, the manufacturing managers know, listen, this is your legacy. We value you. And that's why we're doing it. We're not trying to take people out of the equation. We want to bring your knowledge into the equation.
That's right. Yep. I think machines, when used the right way, will always augment us rather than replace us.
Exactly. Well, Christopher, it has been such a pleasure having you on the show today. If somebody does want to get a hold of you and continue the conversation, what's the best way for them to do that?
I think the best and the easiest way is just to go to our website. There's a contact page there. It's aitomatic.com, just like automatic, but starts with AI.
Okay. All right. Well, wonderful. Well, Christopher, thank you so much for joining me.
Thanks for having me.
I'm Lisa Ryan, and this is the Manufacturers Network podcast. We'll see you next time. Thanks for listening. Hey, do me a favor. If you like what you've heard, please subscribe and give us a 5-star rating. Also, feel free to share the podcast with your friends and colleagues so we can grow the network and connect more fantastic folks just like you. You can either go to the website at manufacturers-network.com or share the podcast on your LinkedIn, Facebook, Twitter, Instagram, or wherever you and your industry friends hang out. The bigger and faster we grow this network, the stronger and deeper community we will have. I appreciate you. Thank you.